Hello students, I welcome you to the Physics Focus YouTube channel. In this video, we will be discussing ray optics PYQ of January 2024 attempt, right? With this video, we are also starting our PYQ series, PYQ 2024 series, where we will be discussing PYQs of January and April attempt of all the different chapters. So in coming days, we will be uploading PYQs of different chapters, right? Therefore, I urge you to subscribe to our channel so that you get regular updates. Also, do consider to press the like button and share this channel with your friends. It supports us. Also, it motivates us to make good quality content and relevant content for you guys, right? So let us start with this. We will start our PYQ of this chapter. Let's start. Yeah. So the first question that we have is, question is there in front of you. What it is given is, two immiscible liquids of refractive indices 8/5 and 3/2 respectively are put in a beaker as shown in figure. The height of each column is 6 centimeter. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha by 4 centimeter. The value of alpha is. So the situation is something like this. Two immiscible liquids, both having 6 centimeter layers. This one having refractive index 3/2, this is having 8/5, right? We have to find out apparent depth. We have to find apparent depth. So how to do it? So basically apparent depth, these will act as composite slabs. The layers, the two layers will act as composite slabs, and we can write down apparent depth as, first of all, this one T1 by mu1 plus T2 by mu2, right? In case of composite slab, this is what is our relation for your apparent depth. So T1 by mu1. So 6 by 8/5 plus 6 by 3/2. When we solve it, 30 by 8 plus 12 by 3. When we will solve this relation, our apparent depth relation will come out to be 31/4. It will come out to be 31/4, and in our question it is given to us alpha by 4. Therefore, alpha value will come out to be 31, right? So answer for this question will be 31. Let us move ahead to the next question. Yeah. So our next question is, we have, if the refractive index of a material of a prism is cot A/2, refractive index is given to us as mu is given cot A/2. Okay, where A is the angle of prism, fine. Then the angle of minimum deviation is fine. So beta, what is our relation? We know one relation about your refractive index in case of prism. The relation is mu is equals to sine of d minimum plus A/2 by sine of A/2, right? This is our relation for your refractive index in terms of minimum deviation and your angle of prism, right? So if you know this, well and good. Otherwise, please keep this relation in mind, right? Okay, now let us substitute all the terms. Mu, refractive index, is given cot A/2. Now cot A/2 we can write as cos A/2 by sin A/2. So cot A/2 I am writing as cos A/2 by sin A/2. This is equals to sine of d minimum plus A/2 by sine of A/2, right? Denominator will cancel out. So ultimately we are getting cos A/2 is equals to sine d minimum plus A/2. Now over here, this LHS side, if you see, we have cos, RHS side we have sine. This cos A/2 we can write in terms of sine as sine of pi/2 minus A/2, right? Cos A/2 I have changed it to sine of pi/2 minus A/2. This is equals to sine d minimum plus A/2. Now we have got on LHS and RHS side sine only. So let us equate the angle. What can we write it? Pi/2 minus A/2 is equals to d minimum plus A/2, right? Ultimately, what are we getting? Pi minus A is equals to D minimum plus A, which gives us pi minus 2A is equals to D minimum. This is our answer. Check the option. Option is your pi minus 2A. Which option it is? Option number 1. Option number 1 is our correct answer. Right? Let's move ahead. Yeah. So our third question is, this is your 29 January shift 1 question. It says a convex mirror of radius of curvature 30 centimeter. Convex mirror of radius of curvature 30 centimeter. So if radius of curvature is 30 centimeter, focal length we know is r by 2 in case of mirror. So this will become your 15 centimeter is the focal length. Fine, well and good. Forms an image that is half the size of the object. So a convex mirror. Now beta, we are aware that convex mirror for a real object always forms a virtual image. Over here, for a convex mirror for a real object, it always forms a virtual image, and virtual image will be erect. Therefore, what can we write? Magnification will be plus 1 by 2. We have two options, either to take plus 1 by 2 or minus 1 by 2. How to decide plus 1 by 2 or minus 1 by 2? Basically, a convex mirror forms a virtual image, and virtual image is basically erect. If virtual image in this case is erect, so magnification will come out to be plus 1 by 2. Fine, well and good. In our magnification relation, what do we know? M is equals to minus V by U. So we can write down plus 1 by 2 is equals to minus V by U. V value comes out minus U by 2. Okay. Now let us substitute, let us apply your mirror formula. 1 by F is equals to 1 by V plus 1 by U. Focal length is 15. V value we got it as U minus U by 2. So minus 2 by U plus 1 by U. When we solve it, 1 by 15 is equals to minus 1 by U. Therefore, U is equals to minus 15 centimeter. Right, object distance comes out to be 15 centimeter. Minus is basically telling us the position that it is in front of the mirror, opposite to the incident ray. Let's move ahead. Yeah. So our fourth question is, it says a biconvex lens of refractive index 1.5 has focal length of 20 centimeter in air. Biconvex lens, refractive index is 1.5. Its focal length in air comes out to be your 20 centimeter. Air means when it is kept in your mu equals to 1. Okay. Its focal length when immersed in a liquid of refractive index 1.6 will be. Okay. So our question says that when it is immersed in a liquid of refractive index 1.6, then what will be the focal length? Let us calculate. What relation will be using? Lens maker's formula. What is our lens maker's formula? 1 by F is equals to mu B by mu A minus 1 by R1 minus 1 by R2. Well and good. Mu B, what is mu B? Mu B is refractive index of lens. Mu A is refractive index of the surrounding. Please don't misunderstand. This is the general formula relation I have written over here. So mu A is refractive index of the surrounding. Let's see in the first case. In the first case, it is 1 by 20 is equals to mu B 1.5 by 1 minus 1, 1 by R1 minus 1 by R2. Let's solve this. So 1 by 20 is equals to 1.5 minus 1. This will be 0.5. That we can write as 1 by 2 into 1 by R1 minus 1 by R2. How much are we getting? So 1 by R1 minus 1 by R2 value comes out 1 by 10. And I will keep this handy. So this value comes out to be 1 by 10. 1 by R1 minus 1 by R2 value. In next, let us see. So when it is kept in your liquid, so what can we write it? 1 by focal length in liquid is equals to mu B by mu A. Now mu B is your 1.5. Now your refractive index surrounding liquid for surrounding refractive index is 1.6. So we will get it 1.5 by 1.6 minus 1 1 by R1 minus 1 by R2 value. We have already calculated from our earlier situation, which is given to us as 1 by 10. So let's see. This comes out to be your minus 1 by 16 into 1 by 10. Therefore, focal length in liquid comes out to be minus 160 centimeter. Minus 160 centimeter. Check your option. Option will be, option is second option. Second option is our correct answer. Let's move to the next question. Okay, so the question that we have is, if the distance between object and its 2 times magnified virtual image produced by a curved mirror is 15 centimeter. Now from the information that is given to us, it is very much clear that they are talking about your concave mirror, because concave mirror can form a virtual image which is magnified. So the situation is something like this, right? Concave mirror, object is placed over here. When object is placed between focus and pole, in that case we get a virtual image which is magnified. How much times magnification? It is 2 times magnification, and because it is virtual we will take it as plus 2, right? Because it is virtual we will take it as plus 2. So what can we write? Plus 2 is equals to minus of V by U. V is equals to minus 2U. Fine, well and good. Now the distance, so what they are saying, produced by curved mirror is, so the distance between them is 15. This total distance is 15. So let's say that this distance we are saying as U. So this distance will be 15 minus U. This is U, so this will be 15 minus U. Now let us put these distances with sign convention in our magnification relation. V value is how much? 15 minus U, and U, because U is this side, so we will take it opposite to the incident ray, so we will take it negative. How much it will be? Minus minus plus, plus 2U. 15U, 15 is equals to 3U. U value comes out to be 5 centimeter. So object is placed at a distance of 5 centimeter. If object is placed at a distance of 5 centimeter, V value is 15 minus U, that is 15 minus 5, 10. So the image distance is 10 centimeter, object distance is 5 centimeter, right? Now let us find out focal length. What can we write it? 1 by F is equals to 1 by V plus 1 by U. 1 by F is equals to V is 10, and U with sign convention it will come out to be minus 5, minus 1 by 5. When we solve it, we get it over here, minus 1 by 10. Focal length is minus 10 centimeter. Minus 10 centimeter is our focal length coming. Be careful with the sign convention. Remain, it is a easy simple question only, right? Let's move ahead. Okay, so our next question is, the distance between object and its 2 times magnified real image as produced by convex lens is 45 centimeter. Convex lens, object, and 2 times magnified real image. A convex lens always forms a real image which is inverted, right? And its magnification is given to us 2 times. 2 times we have 2 options, plus 2 minus 2. Which one we will take it? Because the image is inverted, that implies we will take it minus 2. So M is equals to minus 2. What do we have? Minus 2 is equals to V by U. Okay, well and good. Now they are asking us the focal length. This distance is given to us as 45 centimeter. Let's see. Object distance, if we consider as U, object distance if we say is U, the image distance will be 45 minus U, right? Now let us substitute these distances with sign convention in the relation that we have got it. Minus 2 is equals to V value 45 minus U, right? Real image, that implies it will be your, this for image distance will come positive only, and U will be opposite to incident ray, so it will be taken as minus U. What do we get it? Minus minus plus, 2U is equals to 45 minus U, so 3U is equals to 45. That means distance of object 3U equals to 45, so U value comes out to be 15 centimeter. Okay, well and good. If U is 15 centimeter, V, that is distance of image, will be 45 minus 15, which we know will come out to be 30 centimeter. Now let's use our lens formula. 1 by f is equals to 1 by v minus 1 by u. So 1 by f is equals to 1 by v. V value is 30 minus of u. Object distance is 15. With sign convention, it will come out to be minus 15. Minus minus plus 15. So what are we getting this? 1 by f is equals to 3 by 30. So f is equals to 10 centimeter. Answer for this is focal length will be 10 centimeter. If you will notice, this is the second type of similar type of questions which are being asked in different shifts, right? Earlier, before this, we did same pattern of question for your concave mirror. Now we are doing it for convex lens. Let's move ahead. Yeah. So the question that we have is, it is given in an experiment to measure the focal length f of a convex lens, the magnitude of object distance x and image distance y are measured with reference to the focal point of lens. Basically, the distances are measured from the focus and not from the optic center. Generally, our measurements are done from your optic center, but in this situation, they have given that measurements are done from focus. Let's take a situation. A convex lens is there. Let's say our two focus f2 and f1, right? This is our object, this is our object. Image will be forming somewhere over here. This is 2f2 and this is our image will be. I have taken a specific situation when object is between f1 and 2f1, the image will be forming beyond 2f2. Okay, well and good. Now the distances are measured from the focus. This distance is given as x and this distance to us y. Okay. The y-x plot is shown in figure. The focal length of lens is dash centimeter. Now, how to do this? The graph is in front of you. You will notice that at point C, it is point C. Yes. At point C, at the graph at point C, the coordinates are basically 20, 20. That means at point C we are 20, 20. We are getting 20, 20 at point C. That implies when your x is 20, y value is also coming out to be 20. Well and good. How can we use it? So object distance u, when we measure it, it is always measured from the optic center. So this is x. So this object distance will become how much? This is our focal length. So f plus x, right? So u value we can write as f plus 20. Next, over here, when it is your image distance, if we have to measure image distance, this is our image distance v, this is your focal length f. So v value can again be written as your f plus 20. Well and good. We have got u, we have got v. Now let us substitute this in your lens formula. 1 by f is equals to 1 by v minus 1 by u. 1 by f is equals to 1 by v. V is f plus 20. With sign convention also, it will come out to be f plus 20 only. So f plus 20 minus of u, object distance opposite to incident ray, therefore it will be basically negative. So minus plus f plus 20, right? How much are we getting? 1 by f is equals to 2 by f plus 20, 2 by f plus 20. If we solve it, what we are getting, focal length comes out to be your 20 centimeter. Another way is, if you know a relation, Newton's formula basically gives us a relation which is x square. This is your Newton formula for lenses. What is this relation? X1 is the distance measured from your focus, distance measured from focus of object. X2 is distance measured for image from focus. X1, X2 equals to f square. Again, using this relation also we can directly write it. Directly you could have done it just in 3 steps. Otherwise, obviously we go by our basics, right? Answer for this will come out to be 20 centimeter. Let us move ahead. Okay. Next question. If you look at this question, the refractive index of thin prism of an apex angle A is cot A by 2, then the minimum angle of deviation is. This is repeat question 27, the second question that we did in this video. 27th shift, that is shift 1, 27th January shift 1. Same question was asked. The only difference was that in this case, the 4 options that are given, that are in terms of 180, 180. Over there, in place of 180, there was pi, right? There nothing else. So same question is there. I hope. Let's move ahead. Answer for this one will be 180 minus 2a. There already we have solved it in question number 2. Let's move ahead. Yeah. So our next question is, light from a point source in air falls on a convex curved surface of radius 20 centimeter. Let's falls on it from air. That means this medium is having refractive index 1. This is our object. Light falls on surface. Okay. And refractive index 1.5. That is your radius 20 centimeter and refractive. Is if the source is located at 100 centimeter from the convex surface, the image will be formed at dash centimeter from the object. This distance is given to 100. They are asking us image distance. So let us see over here. This will be normal. This will be normal from your rarer to denser medium. Let us use our relation. What is our relation? Refraction at curved surface. Refraction at curved surface relation is mu2 by v minus mu. So mu2 over here is 1.5. So we can write is 3 by 2v minus mu1, 1 by object distance. Object distance will be considered as negative. So minus minus plus 100 is equals to RT. And if you notice the radius of curvature, to measure radius of curvature, center of curvature will lie this side. For convex surface, center of curvature will lie this side. We will go in the direction of incident ray to measure the radius of curvature. Therefore, R will be taken as positive. So, how much are we getting? 3 by 2v is equals to minus 1 by 100. This will come out to be your plus 1 by 40. Right? This will come out to be your plus 1 by 40. When we will solve it, v value over here will come out to be plus 100 centimeter. And when we'll solve this, v value will come out to be plus 100 centimeter. Now just be careful with one thing over here. Just be careful with one thing over here. Read the last sentence of the question. The image will be formed at dash centimeter from the object. So v value is 100 we got, but in the question they are asking us distance from the object. So this distance will be how much if we have got v as your 100. 200 centimeters. So please be careful with this. Very small minor thing is there, but it will change your answer. Let's move ahead to the next question. Yeah. So this is our last question for January attempt. This is your 1st February shift 1 question. Let us see. The distance between object and its 3 times magnified virtual image as produced by convex lens is 20 centimeter. Convex lens will produce virtual image when object is placed over here and it forms on the same side, right? Virtual image is formed and it is your magnified. So that means the image will be erect. Magnification is how much it is 3 times. Should we take plus 3 or minus 3? It depends on whether the image is erect or inverted. So virtual image will be forming erect. So we will take it plus 3. Now let us see, we know m is equals to v by u. Therefore we can say 3 is equals to v by u. Now it says that the distance between them is 20 centimeter, the focal length. Okay, well and good. This distance is 20 centimeter. If we say that object distance is u, If object distance is u, image distance v can be written as 20 plus u, right? Now let us substitute them with sign convention. So what we will get it? 3 is equals to minus 20 plus u by minus u, right? What are we getting? 3u is equals to 20 plus u, which gives us 2u is equals to 20. So u value comes out to be 10 centimeter. Object distance comes out to be 10 centimeter. So your image distance v value will be come out to 20 plus 10, that is your 30 centimeter. Now let us substitute this in our lens formula. 1 by f is equals to 1 by v minus 1 by u. This is equals to 1 by v, which is minus 30. It's a virtual image, it will form on the same side, right? Minus of minus plus 1 by 10. How much are we getting? 3 times 3 times. So this becomes your 1 by f is equals to 2 by 30. So f is equals to 30 by 2, which is your 15 centimeter. 15 centimeter. So our answer for this one comes out to be your 15 centimeter is a correct answer, right? So with this, we have discussed the questions related to your ray optics for January 2024 attempt. I hope you like the video. Do consider to press the like button and subscribe to our channel for further videos that will be coming ahead, right? So thank you very much. Bye bye.